Sorry I can't be there today, but today we're going to do a 10.8 day 2 notes. Okay, so on here we're going to talk about two different vocabulary words, permutation and combination. A permutation is when order does matter. Okay, and we're going to be using this formula when order does matter. Okay, super important for you guys. Looking at the examples, these are great examples to put on a note card. Putting people in order, electing officers for a club. Officers would be a president, a vice president, a secretary. Okay. Putting letters in order to spell a word. Notice in order, in order. Seating a group of people around a table or at a play. Okay, so order does matter. You don't think about sitting next to people, it changes. And the order that people can win a race, first place, second place, third place, or this last one, setting a code on a lock. Okay, if you did 1, 2, 3, that's different from 2, 1, 3. Okay, so this permutation order does matter. Combination order does not matter. Okay, and if order does not matter, we use the combination formula. Okay, and again, we have a bunch of different examples. Arranging flowers or balloons for a bouquet. Okay, think about you're getting all the flowers and balloons no matter what. Okay, making a fruit salad or a vegetable salad. Okay, all the ingredients are going to be in the salad anyways. Selecting a team of students for a group. Okay, selecting pizza toppings. It doesn't matter if they put the pepperoni or the sausage on first. And then choosing ingredients to put on a sandwich or pizza or something similar like ice cream. All of those are combinations. Okay. Now these two different formulas, there's two parts in each of them. There's an N, which is the items taken, so the number of items taken, and there's R, the number taken at that time. So kind of your options and then how many you're choosing. Options and then how many you're choosing. Same thing for combination. Okay, it's just in a different order. And remember this exclamation mark. Okay, that means we're going to count down as we multiply. So let's try some. Remember our formula, if we're using a permutation, our formula is n factorial over n minus r factorial. Okay, and if we're working with that, okay, we have our n and we have our r. Okay. So I'm going to take out this n and I'm going to put a 3. I'm going to take out this n and put my 3. And I'm going to take out this r and put a 3. Okay, I replaced them with my numbers here. Okay, once we have that, we always do our parentheses first. 3 factorial over 3 minus 3 is 0 factorial. Well, 0 factorial is the same thing as 1. Okay. So now we just have to find out what 3 factorial is. Well, that's 3 times 2 times 1, which is going to be 6. 6 over 1 is just 6. Okay, let's try again. Okay, now we have our n factorial over n minus r factorial. Okay, take out the n, we're going to put 5. Take out this n, I'm going to put a 5. Take out this r, and we're going to put a 2 because it's n and r. Okay, go ahead and solve. We have 5 factorial over 3 factorial. Okay, now remember, we're going to count down until we get to that bottom number. So it's 5, 4, 3, and I can stop. I stop by putting my factorial sign. On the bottom, I have 3 factorial. And we stopped so that we could cross stuff off. We can cross off both the 3 and that factorial symbol. Okay, so now all we are left with is 5 times 4, which will give us 20. Okay, let's try again with 16 as our n and 1 as our r. Okay. So n over n minus r. Take out the n and put 16 on the bottom. N is 16, r is 1. Okay. Do your parentheses, so 16 factorial over 15 factorial. And on the top, we're going to count down until we get to the bottom number. So 16, 15, stop, factorial. So keep the bottom and see what crosses off. We're going to be left with just 16. Okay. Okay, let's look at combination. Now, combination is very similar, but we also need to put an r factorial in front on the denominator. Okay, so it's still n and r. We use my formula, n factorial over, gotta make sure I got it right, r factorial, and then in parentheses, n minus r factorial. Okay, now let's replace what we know. N is 3, so I'm going to take out these n's and put 3. I'm going to take out the r and put 3. And we're going to solve. We do our parentheses first. It's 3 factorial over 3 factorial. And then 3 minus 3 is 0 factorial. Okay, now remember, 0 factorial is just 1. Okay, so it's kind of like it's not there. On the top, I have 3 factorial. I would need to count down until I get to the bigger of the bottom. But since I already have a 3 factorial, those are going to cross off. Okay, remember, if there's nothing on the top, there's still a 1 there. So my answer is going to be 1. Okay. Comparing the same numbers. Okay. So notice we had a 3 factorial, or a 3 and a 3, and a 3 and a 3 for the permutation and the combination. Okay. For a permutation, it's always going to be just that number factorial. And on the bottom, it's just going to be 1. Okay. Or with a combination, it's just going to be 1. Okay. Now, that's not always going to happen. That's just with if the numbers are the same. Okay. Let's look at when the numbers are different. Okay. So I'm going to start with my formula. I'm going to replace those values. So take out my n and put my 5. Take out my r and put my 2. Okay. I'm going to do my parentheses. So I'm going to keep 5 factorial and the 2 factorial. And then 5 minus 2 is 3 factorial. Okay. Now, I'm going to use my top number and I'm going to count down to the bigger of the bottom. So I'm going to do 5, 4, 3, and I'm going to stop with my factorial sign because there's a 3 factorial on the bottom. So I'm going to write that right away. Okay. But there's still that 2 factorial, so I still need to count that down. So I'm going to do 2 times 1. Okay, so I counted down 2, 1. Okay. The 3 factorials will cross off. Okay, and this is where it's a little bit extra step. 5 times 4 is my 20, and 2 times 1 is 2. We do need to make sure we simplify that. 20 divided by 2 will give us 10. Okay. Now the difference between permutation and combination when the numbers are different aren't very there's nothing noticeable. Okay, so those ones you're really going to have to be careful with your formula. Make sure you use your best handwriting. Our last one is 16 combination 1. So let's try that. We're going to start with our formula. We're going to replace our values. Take out that n. Okay, I still have an r. Okay, now we can do our parentheses. So I have 16 factorial over 1 factorial, 15 factorial. Okay, and we're going to count down. Okay, I'm going to do 16 times 15, and I'm going to stop because there's a 15 factorial on the bottom. On the bottom, you have 1 factorial. Oh, hang on. I need to count that down. Oh, wait, 1 factorial? I can't count that down. It's just 1. So we do 1 times 15 factorial. So that 15 will cross off. And we're going to be left with 16 over 1. Okay. 16 over 1 will just be 16. Okay. When you have a number and then a 1 for permutation versus combination, you do have the same answers, and that's just because that 1 factorial that you're going to also multiply, it's not going to change our value at all. Okay, so those are 3 different examples for each permutation and combination. The biggest piece of advice I can offer you is to make sure you are keeping your N and your R separate from each other. Okay, write it out and then erase it. It really helps, I promise. Okay, so go ahead and try these student practice problems. Don't forget your formulas. This next part is going to be talking about word problems. Okay, now we already know that these are permutations because of our directions. Okay, but we need to be able to choose our N and our R. So let's go back to that front page and look at permutations and N versus R. Okay, so permutation, the N is going to be the items taken. So how many options? The R is going to be how many we're choosing. Okay, so N, how many options, R, how many we're choosing. Okay, so a family of 5 wants to be seated together at a school play. How many ways can they be seated in 5 seats? Okay, so our question is going to be a permutation, so I'm going to put that P. Our N is how many to choose from. Well, that's the whole family, right? Our whole family is 5 people. Okay? And I want to put them into seats, but all of them are going. So we have 5 different seats. So there's 5 permutation 5. Okay? And it does say solve, so we're going to go ahead and use our formula. Our formula for permutation is N factorial over N minus R factorial. Go ahead, replace your values. Do your parentheses. Oh, 0 factorial, remember that is just 1. So 5 factorial over 1, we're going to have to count down that 5. 5, 4, 3, 2, 1. Those 1s can cross off, but we're still going to have 5 times 4 times 3 times 2. That will give us 20, 60, 120. So 120 ways. Let's try another one. 12 people are participating in a writing contest. How many ways can the first, second, and third place winners be chosen? So it's a permutation because there's order matters. If you would rather get first place than third place. Okay, so 12 people are participating. So my choice is 12 people. I am choosing 1, 2, 3 of them. Okay, so I have my N is going to be 12. That's how many I'm choosing from. And I am choosing 3. Now let's put those into our formula. N factorial over n minus r factorial. Replace your values. I have a 12 and a 3. Okay, do your parentheses. 12 minus 3 is 9. And we're going to count down on the top until we reach the bottom. So 12, 11, 10, 9, stop. We're stopping because those 9s will cross off. So now we need to know what 12 times 11 times 10 is. And I'm going to have to pause and grab my calculator because I do not know that one. Okay, it is a bigger number, and that's okay. It is 1,320 ways. Okay. Let's try one more permutation. 8 students tried out for 4 different roles in a school play. How many ways can the director fill the roles? So how many are trying out is 8 and 4 different roles. So we're choosing 4 of them. And this just means that there's a difference. If you wanted to be the star of the show, that's different than if you are a like part of the choir or part of the crew. Okay, so we have 8 to choose from. It's still a permutation, and we are choosing 4. Let's put those into our formula. Okay, change out your numbers. And solve your parentheses. Now remember, count down on the top until you get to the bottom. So 8, 7, 6, 5, 4, and stop because we have that factorial. Cross off that 4 factorial and then go ahead and solve that top. 8 times 7 times 6 times 5. Again, I'm using my calculator because I don't know that. It is 1,680 ways that the director can fill the roles. Okay. Now those are your permutations. Remember, order matters. Okay. You have some practice problems like that. Our last example for today, okay, are combinations. Okay, I know it's a longer set of notes. That's okay. Combinations. Remember, N and R mean the same thing. So N is how many to choose from. R is how many we're choosing. Sam is making a fruit salad. He has 5 fruits to choose from: strawberries, bananas, kiwis, grapes, and apples. Sam only wants 2 types of fruit in his salad. How many different fruit salads can Sam make? Okay, so how many is he choosing from? 5. How many is he choosing? 2. So 5 combination 2. Go ahead and put those into our formula. Remember, using our combination formula now. Okay. Go ahead and replace your values. Okay. And then we get to solve. Remember, we do our parentheses first. 2 factorial over, it looks like it's a 3 factorial. We're going to count down on the top until we get to the bigger of the bottom. So I'm going to go down to that 3, 5, 4, 3, stop. And I know that 3 factorial is going to cross off. But I still need to count for that 2 on the bottom. So I'm going to do 2, 1. And I'm going to go ahead and solve that. We're left with 5 times 4 over 2 times 1. 5 times 4 is 20. 2 times 1 is 2. 20 divided by 2 is 10 ways to make his salad. Okay. Okay, last one. In a class of 10 students, how many ways can a club of 4 students be arranged? So how many are we choosing from? 10. How many are we choosing? 4. So 10 combination 4. Put those into your formula. Replace your values. And then we get to use our parentheses. So 10 over 4. 10 minus 4 is 6. So we're going to count down to our bigger, which is that 6. 10, 9, 8, 7, 6. Stop. Because that 6 factorial will cross off. We can't forget about that 4 factorial. So let's continue. 4, 3, 2, 1. And I'm going to need my calculator to solve this one. 10 times 9 times 8 times 7 over 4, 3, 2, 1. So we have 5,040 over 24. And we're going to divide that to get 210 ways. Okay, and you have 2 more student practice problems that are combinations. Okay, the hardest part about these problems are figuring out, is it permutation or combination? So make sure you practice the formulas because the rest of it's hard enough as is.